In this video, we're going to look at a past exam question about proof by induction, and this one specifically focuses on divisibility. So show u of n plus 1 and minus un would be equal to this function. Well, un is given to us in this expression. U of n plus 1 would be what you get when you replace everywhere where there's n on the right hand side with just n plus 1. So it will be n plus 1 all squared plus 3 lots of n plus 1. Now, a lot of students make the mistake of just doing n squared plus 1, but I'm sure you guys know, because you're doing A-level further maths, that when you square something, you're just multiplying it by itself. So you can write it out as two separate brackets. That would then expand to n squared plus 2n plus 1. This bracket here would expand to 3n plus 3. Collecting the like terms, we'll get n squared plus 5n plus 3. That's your expression of un plus 1. We then subtract from that the expression of un, which is already stated here. So that's n squared plus 3n. N squared take away n squared cancels out. 5n take away 3n is 2n. So we'll have 2n plus 3. Okay, I must have made a mistake somewhere. Yeah, I did. The 1 plus 3 is 4. So always, that's the benefit with these show that questions. You can spot the mistake that you make along the way. It's fine. Everyone makes mistakes as long as you just... And it's very important you read over your working out, just in case that does happen. But now that we've done that, let's erase all this and move on to part 2 of the question. Hence, proof by induction, each term of the sequence is divisible by 2. Okay, so what we're going to do is assume, oh wait, even before we start with that, we start with the initial case, don't we? So because it says for all positive integers n, that starts from 1 upwards. For the initial case, we're going to take the smallest value that n could be, which is a positive 1, and substitute that into both sides of the expression. That would make u1 is equal to 1 squared plus 3n, which is 3 and 1, and we have to check if that's actually divisible by 2. 1 plus 3 is 4, which of course is divisible by 2, and you can just say that by factoring out 2 from it and showing that there's an integer inside the bracket. We're now going to assume for induction that for n is equal to k, we need to make it match what mentioned before. So we say for positive integers k. I'm just going to very quickly write that out. We want to form the expression that uk is equal to k squared plus 3k. Now, one tip I'd give you guys with the divisibility proof by induction, this show that part, it does come in useful, and you'll see how it comes in useful actually. Now, one thing I advise my students to do is just make a little statement of what you want to show. We want to show that when you express n as k plus 1 instead of just k, so u of k plus 1, that's equal to k plus 1 all squared plus 3 lots of k plus 1. So let's just write that out. 3 lots of k plus 1. Now, from there, we can expand out u k plus 1. And to find it, actually, if we rearrange this expression, that shows that if we add un to the other side, we get that it's uk plus 2k plus 4, actually. Of course, replacing everywhere where there's n with k. That's useful because we always want to use the inductive hypothesis that we assume. And here we can use it directly. We can replace uk with k squared plus 3k. We'll then have k squared plus 3k, and then plus everything else that was already there. We can then simplify that because 3k plus 2k is 5k. And then you can factorize that. When you do factorize it, actually, do we want to factorize it? Even though we can, I think if we want to show that it can be written in this format, but we actually can, because that if we expand out k plus 1 squared plus 3 lots of k plus 1, we actually end up getting to this expression here. And so, yeah, that's... Oh, but does that show that it's divisible by 2? So that's the bit of the question that was missing here, actually. So I don't know why I made so many mistakes in this video. But if we're assuming that it's divisible by 2, we have to say that it's a multiple 2 of any integer. So 2a, where a is an integer. And then let's think about how we can now show that the expression that we formed just underneath. So underneath here, everything that we did is correct. But how do we show that this expression here is a multiple of 2? So what I wrote for what we want to show is what we typically do for proof by induction questions. But for divisibility questions, it is a little bit different. Because where our sole focus is just to show that this expression that we've ended up at is always a multiple of 2, using this inductive statement. Well, if we think about it, we can separate this into k squared plus 3k instead of collecting like terms plus 2 lots of k plus 2k plus 4. That's useful because we already know that k squared plus 3k is a multiple of 2. And once you write out this expression, we can actually factor out the 2 from each individual term. That'll be a plus k plus 2. And then now, no matter what integer a is, if you put it into this expression, it's always going to put out a factor of 2, or a multiple of 2, sorry, because we factored out 2 from it. So with these divisibility questions, you don't want to do what you want to show. Instead, you want to introduce the expression as a multiple of whatever you're trying to divide by and try to include that somehow into finding u of k plus 1, showing that uk plus 1 is also going to be divisible by 2 when uk is divisible by 2. Sorry, I don't know why I made like 2 mistakes in this video, but hopefully it did help you guys. Be sure to leave a like if it did and subscribe. I'd appreciate it a lot. Thanks for watching your video. I hope it helped. If you have any tutoring inquiries for A-Level Further Maths, be sure to hit my website up at www.excellineducation.co.uk.